to, this is Gate PM 2024. So since the paper is out, students have been asking for a solution, and I had decided I'll put up the solution somewhere during revision. Gate BM 2024. Okay, this is Gate 2024 exam, Biomedical Engineering. Okay. Does anyone know the All India rank 1 marks on this? So this is out of 100. Most of you would know that. How much did All India rank 1 give? There's a student who got notes from me, right? Sanjeev, not 64, 65. Okay. So this is approximately 54. Sanjeev Acha, right? Oh, he was a IN student. Okay. And he scored 54 in the actual examination. Okay. Hey, just for the reference, I can also, take this, edit this out. Shamaita, how much did he score? Just for the reference. For some reason, couldn't perform well in the examination day. Okay. Somehow, she, that examination day did not go in her favor. She scored 28 out of 100. Okay. Now, is given the test again, she has scored around 70, I think. And most of the students who are preparing this year scored, around 65 with preparation. Top score is close to 70. I presume most of you, have done this poorly, so I'm not going to question any of that. So this is very, very good. Okay. One is I feel that this year the preparation has been really, really good. Okay. And most of the students, the students who are in the 60 plus range for some reason, okay, we have this knack of identifying really good students. All right. All the scholarship students, you are in this range. Okay. So that is very, very, very good. And surprisingly, so most of the scholarship students this year happen to be from one single college, right? One single college from Chennai. And yes, I'm saying this well before the GATE 2025 examination. Did you expect many toppers from one single college from Chennai this year? Okay. That is my expectation. Let's see, what happens after the examination. Because, the faculty in this college happened to know me. And then he kind of recommended many of his students to the program. Okay. So this is my prediction about the 2025 paper. But anyways, so I wanted to put that on record. Anyway, so if you look at 2024 paper, so the All India rank scored 54. The toppers here scored 65, 70 and all that. I need to score 95 plus so that we have solutions available for everyone, right? We'll do that today. 95 plus, of course, with about 4.5 hours of solution solving. Okay. Took me 4.5 hours. This paper, the students are kind of stabilizing. Okay. What to expect from the biomedical paper? Okay. The students are getting stabilized. But this 2024 paper is telling even the committee is getting very stabilized. So this is the best paper for. The paper is full of this. I suppose this is IIT Bangalore, right? The paper is full of class. This is testing you whether you know biomedical engineering or not. Okay. Also seems like one of the design criteria in setting a GATE biomedical paper is that no unfair advantage should be given to students from other branches, say electronics or something like that, right? So for this year, they have ruled out electronics from the as a second paper. Okay, So electronic students cannot give biomedical as a second paper. They can still give biomedical as a first paper. Even mechanical students, civil students can give biomedical as a first paper. That's a different story. But to not give any unfair advantage, so far they have been making non-biomedical questions like electronics, analog, digital electronics questions very hard. Okay, so it's not a cake for those electronic students, and they score easily. Okay, so far looks like that's a design criteria. But this year, that has been addressed in a very, very interesting way. Okay. My impression, the engineering math questions are really, really hard. Okay. That is what I felt. Engineering math questions, some of the questions are very hard. Okay. But I presume this is what you expect from, okay. IIC Bangalore is one of the best papers. And today's objective, we'll discuss solutions for this. Okay. So with preparation, I'm going to get, 95 plus 98, even 100 and all that. We know the key, right? So that's not hard, but we want to answer 95 plus, you know, marks reasonably. Okay. Justify the answer and all that. Justify, verify, and on all that. One more thing, this paper also had the least number of mistakes or issues in the question paper. Answer key is like blatantly there is a mistake. Sentences are ambiguous. All those things are kind of avoided. Okay. So whoever is preparing this, you should take this as a standard. Okay. This paper should be set as a gold standard. If a student is preparing, what do you expect? Okay. Where do you stand? How do you test yourself? This paper, yeah, you need to test your performance with respect to this paper. Okay. And so far, complete solutions is not available. Okay. Today we'll make it available. Okay. Today we'll discuss, and then later on I'll make it available. And try to do this in about 3 hours. Okay. Not more than 3 hours. So wherever questions need some justifications, and where justifications can be reasonably provided, I'll do that. Okay. Most of the questions, most of the answer key, most of the answers can be derived in 3 hours. Okay. I think one or two questions I'll have to do towards the end. Some of the engineering mathematics questions, but most of the questions we can kind of go solve it and also justify it. So let's get started. But wherever we need to, like, we have to be fast. I'll just do this very, very fast. So with increasing order of intensity, then meanings of the words. Simmer seed, smother. Okay. You're heating things with increasing intensities, right? Synonyms with varying intensity, specifically increasing intensity. What you need is synonyms with, again, increasing intensity. Break, raise. Okay. Obfuscate doesn't make sense. Fracture, fissure, obliterate. I think the highest intensity for break would be obliterate. Okay. Let's pick that. Increasing intensity. Okay, fine. The houses are numbered in the following way. House numbers on one side of the road are consecutive odd numbers starting from 301, while on the other side it's 302. Total number of houses on both sides are roads. Yes, okay. So you have a road. Let's put a line, okay. If we know how to draw a line, we know how to put a road, right? How to then construct a bridge and how to send a rocket. So drawing that line is a difficult thing, okay. So we have drawn a road. 301, 303, and it goes on like this. Here we have 302, 304, and it goes on like this. Difference between this sum and this sum. Okay. You could do this. You can put that, Gauss anecdote hat. Quickly see that the summation is this difference is 1. This difference is 1. Okay. For one pair of houses, difference is 1. Two pair of houses, difference is 1. The summation to be 27. Okay. There needs to be 27 pair of houses. 27 pair of houses. Okay. Fine. You could do the sum and all that. That also there is a shortcut, right? Number of terms and the average value. These are both odd numbers and even numbers. These are linear series. You could do it that way, but you could get the answer faster this way, I suppose. This question, again, most of you would have done. Things are on the numerator. How do we undo the numerator? So take log on both sides. So this is p by q log p, okay, minus p by q log q. Okay. If you do that, log of this is p by q log p. Okay. P by q log p as log p. It came here. I took log on both sides. It's fine. So yeah, I could quickly see some of the things canceling. This cancels. This cancels. Okay, now we have fairly easy. P log q is q log e. Minus minus cancel. This q came to the side, and then q per p is p per q. Right? We could answer at this stage. Let's go to the next question. Which one of the given options is possible? Value of x for the following sequence. Quickly, we are used to standard primes, squares, cubes, and all that. This powers of 2. Okay, bits, binary, bytes, and all that we know. So this is 4 minus 1, 8 minus 1, 16 minus 1, 32 minus 1. Given day, how many times will the second hand and a minute hand of a clock cross each other during the clock time 12:05 to 12:55? This is fairly easy. They cross once every minute, and then there aren't no chill minutes. Chill minutes. Dot dot dot. Okay, for brevity, that makes things 55 minus 5. This is 50 minutes, right? Once every minute, 50 full minutes. This should be 50. And I am doing this because we don't really have to worry about any partial startings, partial endings, and all that. Okay, that makes this reasonably easy. So we'll move on. Next question. In the given text, blanks are numbered 1 to 4. Select the best match for all the blanks. Okay, hold wait. This is singular plural, right? Let's mark the singular plural. Okay. Athletics is singular. Okay. Crowd is singular. And then person doing, he begins to cross up. 6 cross steps. 6 cross steps. This is plural. Abrata as his body is singular. So wherever there is a singular, you're expecting a word ending with yes, 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 right? Yes, 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 and no yes here. That makes this a correct answer. Athletics holds the potential for spectacle. The crowd waits, right? The crowd wait is again, spider sense. That's all right. Fine. Let's move on. Three distinct set of indistinguishable twins are to be seated at a circular table that has 8 identical chairs, unique seating arrangements. Okay, can anyone quickly explain this? So this is like 3 and 8, 3. So three distinct sets of indistinguishable twins. There are three twins. Then this is also a circular table. There are 8 positions, 6 people, 8 position. How many unique seating arrangements that are defined by relative position? So in the circle symmetry and all of that is there. How many unique seating arrangements are possible such that each person is sitting next to her twin? Okay, if you look at each twin pair, I am getting one answer as this 4 minus 1 factorial into 2 factorial. This is considering each twin pair as a single person. Okay, so I'm going to do this as a old school means. Twins are different, right? Distinct sets. Twins are distinct. So X, Y, Z. X, Y, Z. Okay. And then you have the X is located, that is log, right? Without laws of generality. This is circular symmetry is there. But you can have X, Z, Y. See, for 3 pairs of twins, there are 2 positions. There are 2 possibilities here. The twins are all together. X is a twin, Y, that's a twin pair is a twin. So X, X, Y, Y is Z. Okay. Now, so, now comes the second thing. Identical chairs. This says this is like 6 people, right? That is 2 gaps. So look at the possibilities. So there are 2 possibilities here, how X, Y, Z are sitting, and then how many possibilities the gaps are there, right? So you have twin, 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 gaps like this. Okay. Twin, twin. So there are like gaps, 2 gaps here. That's gaps 2 at a time. There are right now 1 possibility, second possibility, third possibility. Then we can also do gaps 1 at a time. It can be this. It can be this, or it can be this. Again, it's a circular table. So where the gaps are doesn't matter. So here is the 4th possibility, 5th possibility, 6th possibility. In the top, I have two gaps at a time, and then gaps are separate, right? Total six possibilities. So you have six into two, this many possibilities, and in each possibility, these many cases, right? Six into two, that makes the answer 12. I somehow did it as a old school format, okay? But I can get the answer for, I took 2-3 minutes, okay? That's fine. Chart given below compares the installed megawatt for capacity. Okay, capacity is electric generation by installed capacity. You have electric generation here, electric generation, or this into marks, that is in the numerator, and then you have the installed capacity here, right? That is in the denominator. Fine. You want this capacity factor to be higher. Numerator should be as big as possible. Denominator should be as small as possible. So that quickly rules out denominator is too big. Relatively ratio, right? Relatively denominator is too big. This is between this and this. If I stare at it, it can technically make a mistake. So for T1, this is 10,000 by, the common factors and all we can forget. 1,000 hours and all we can forget. This by 15. And for T3, you have 7,000 by 15. So this is 20. Thousand divided by 20, 500. 1,000 divided by 15, 466. Just to be on the safer side, I calculated those two numbers. Okay. So that makes us, which one of the given technology has capacity factor? This is this number, option A. On to the next question. Minesweeper, is that first D? So I have already seen the questions. First three columns is either a cross X number given below. Rule cell represents an account crosses its immediate neighboring cells as per the store maximum number of process possible. So this is interesting. So there are multiple solutions possible at this stage. It is what makes the game interesting. Let's give the two possibilities here. Going to draw the last column. Okay. And technically we shouldn't have any confusion. So let me kind of draw it here. The last column, two. I think there are two possibilities. So if there is a cross here, this is checked. Two diagonals. This is checked. Diagonal and left and right. This is checked. This is, diagonal is left bottom. All right. This is also checked. That is one possibility. So I am going to draw that here. Possibility one. Solution one. Is there any other solution? Let's erase this off. If we have a cross here, 2 is set, 3 is set, 4 cannot have a cross here. That is forbidden. Forbidden. There is a bomb there. You can have a cross here. Because if there is a cross here, 3 gets violated. 3 gets violated. You need to have a cross there. This is solution 2. Whatever information is given. Have any more crosses? If you put anything else, I think let's also just let's start with the cross or the violated positions. Okay, let's see what happens. Put a cross here. 4 is set. Have a cross here. Hey, there is one more solution, but that also is 2, right? It's is 2 so far. Can we have a cross here? So 2 is set, 3 is set, 4 is also set. Yeah, this is our original solution. So yeah. So I think maximum is 2. We'll answer at this stage. Okay, there is a solution 3. So analytical aptitude notice is not one question, but anyways, we answered it. The max possible is 2. I don't think 3 is possible here. During a half moon phase, sun earth moon form a right angle triangle if the area of this thing is measured 89.5 degree. So now the question is, hey, let's draw the sun for the reference. Let's draw the earth for the reference. Let's draw. Hey, is the moon, earth, sun. Let's draw the moon here. Yeah, drawn it as if this angle is 90 degrees. Is that correct? Of course, this is our sun, our earth, and our moon. It is suggesting that based on my diagram, this angle is 89.85 degrees, and I have drawn such that the right angle is here. This half moon phase, so if it is here, is correct. Can someone just confirm this? Other possibility is the right angle shows up at the moon. Are we seeing half a moon? Okay, let's calculate what this is. Okay. What we need is the AES by EM. S by EM. Something is telling me this is not correct. Okay. S by EM right now is just tan. Have this certain degrees. 82. Okay. 82. Can someone quickly confirm? For some reason, this is my confusion. Okay, quick confusion at this stage. So, is it the because this half moon? I'm like slightly wondering where that half moon is. What that convention for that half moon, right? I'm slightly wondering about it. I'm not sure if this is going to give you a different answer. Okay, this will likely give you a different answer if this is 89.85 and if this angle is 90 degrees. Notice in this case, moon is like half, right? Yeah, this slight angle is somewhat confusing. Anyways, what happens in this case? This is ES by EM. ES by EM. Okay, is by EM. That is 1 over was 89.85 degrees. That is also 382. Okay, unnecessary confusion. Anyways, so I had that confusion. I got it clarified. Okay. Hey, we are done with that video. Oh, there also you're getting the answer. Okay, so it doesn't matter. Hey, what is the value of the complex line integral counterclockwise? Z is 3. Quick, 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 quick. So most of you would have done this. This time, what I noticed, 80% of the questions did not show up from 20% of the concepts, specifically engineering mathematics. Okay. Okay, this is Z is 3. Okay, this is radius is 3. Okay, this radius is 3. And then you have 0 and 2 are inside. Okay. Okay, let's draw the 0 and 2 are inside. There are two poles inside. The fourth pole is outside. You don't have to worry about it. So this is summation of residuals. There is a 2 pi j factor into residual at 0 plus residual at 2. A single first order residuals. Know how to do this. So this is 2 pi j into residual at 0 is 8 by minus 2 into minus 4. That is 8 by 8. Okay. Plus residual at 2 is 8 by 2 into 2 minus 4. Okay. That is 2 into 2 minus 4, I suppose this is. Minus 4. We simplify this. How much do we get? Oh, no, 1 minus 2. That's a minus 1. So we have minus 2 pi j. Right. Then the equation. Hey, these are actually not not 80% of questions. Actually, two questions are fairly straightforward. Newton-Raphson, right? Your f of x x minus 2 cos x. You're trying to solve for f of x equals 0. Also need Newton-Raphson the derivative that happens to be 1 minus 2 sine x. Newton-Raphson xn plus 1 is xn minus of x by f dash of x. They given in a reasonably simple format. Answer is A, I suppose. Okay, one more math questions. Fairly easy. In repolarization phase of the neuron, how many sodium, potassium? Hey, what was the mnemonic for this? 3Na2K? Salt, but salt, more salt outside, but this is a transport, right? More salt outside. This is inside outside concentration difference. But during active transport, 3 is going versus 2. K kids. Yeah, the refacing still, 2K kids. And, E, 3Na. Yeah, fill up a mnemonic there. That's not our objective right now. Cardiac rhythm, healthy heart originates from heart of the heart, son of the heart, cyanoatrial. The following events is not typically encoded in diagnostic X-ray projection radiography. Z, too high. High for what? Agnostic. This not typically encountered. The following statements is true for PET imaging. Two coincident photons. There is pair production 511 kiloelectron energy are detected 180-degree apart. 11. Rest mass energy of electrons. So if you know mass of electron, you can technically calculate this. You also need to know, so you need to know mass of electron. It should be somewhere else in the question paper. I'm telling you, just in case you are not able to answer this. And then you need to know joule to electron volt conversion. That if you know the charge of an electron, right, do that conversion. Given this, you can calculate this, but anyways, we'll recall it and move on. Consider the following layers. You have subcutaneous, viable dermis, stratum corneum. Which one of the following represents the correct sequence? Okay. So first, let me tell you what I would have done. Okay, just in case I didn't know the thing. The AP is going to be outer. I ruled this one out. Okay, AP has to be the outermost. And I ruled that one out. I couldn't rule this one out. I couldn't rule this one out. Subcutaneous fat expecting deep inside. This is fairly so. Is the question between these two? Okay, correct answer is this. Bioclass 45S as a composition of this 48% silica, ratio of calcium and phosphorus. Okay. Option E, T5S, 5:1 ratio. Convention, okay, conventional definition. Macrophages that are resident in the liver are pro is something connective, I suppose. This is skin, I suppose. Histio is a sort of like I feel like going for histio size, but I think this is Kupfer, right? Recall based question. We'll quickly move on. One of the following drug release kinetics will be ideal for developing an implantable slow release drug device delivery? Is a nice question because it is this cumulative release. Cumulative, there is increase and then there is decrease. Negative release. Drug is absorbing. Okay, unless it's designed to do that way, it doesn't make sense. There is absorption going on. This makes sense. This is release. Constant release that will give you a cumulative. If you integrate a constant, it's a line, right? So this is a nice candidate. This is actually, if you integrate this, you get this, right? It's not a constant release. This is like a sudden corona wave, right? This is incorrect. This is absorption, negative release. Negative release. This is absorption. Again, this is not correct. Is correct. Electronics. How many of you recognize on this? Which digital circuit block is this? Okay, I have suggested you to skip this. Did any of you can recognize this? All of us know the answer. No, right? Okay, in that case, no harm done. This is negative level trigger T latch. Okay, not discuss further. Fourier transform of e power minus 2t. At least know the definitions of Fourier transform, Laplace transform, and all that. All the DFT, DDFT, DFT, DDFT, FT, Fourier series, and all of that. So use a definition. I'm integrating the dummy. This is exponential. What you are dotting with is exponential. Fairly easy. So perhaps you could call. I'm going to, at this stage, I make the call. Let's do that. Mod X. You can put a equal to perhaps here if you want. This is positive value. This is positive. For negative value, this is minus t. That makes that 2t. Instead of mod X. Okay. So this integral, if you have to calculate the integral, that kind of splits up. Okay. Answer, let's do this. Answer equals, I'm going to split the integral right away. 0 to t, e power minus 2t, e power minus j omega t dt plus 0 to infinity, e power plus 2t, and this is minus 2t, e power minus j omega t dt. Dot power integrate this. Zero, this is one, this is minus infinity, that's 0. So I'm going to write numerator as 1. Infinity, this is 0. Then if you put this 1, this is minus 1. Well, whole thing is -1. Okay. 1 by 2 minus j omega minus 1 by 2 plus j omega. 4 minus j square omega square. I suppose at this stage I know the answer is P. Okay. Denominator, quickly also I see that j omega will cancel. 2 plus 2 will give you 4. Okay. Type plot of a second order low pass filter. Did anyone do this? Great. Because this is an easy question. If we get a correct, you are going to easily get a lead. Okay. You are going to get an edge. Second order low pass filter. This is 40 dB per decade. That is for every change in 10 hertz, you will have a change in 40 decibels. The slope here is 40 decibels per decade. So if you go 2 decades, the change is 80. Okay, from 1 kilohertz to 2 decades, you have to go to 100 kilohertz. Okay, so this is needs 2 decades in 2 decades. The first order system, this is typically 20 decibel per decade. Second order, this is 40 decibel per decade, right? So from 1 kilohertz into 10, right? That is 2 decades. Okay, let's go to the next question. Impulse response of the system. Delta of T. T of S to H of S. A of S by T of S. And how do you define the impulse response? How do you do? This is transfer function. How do you get the impulse response? So X is I know there is a quick way to connect transfer function and impulse response. Did anyone do this? When I saw this, actually, I didn't read the question fully. I just presumed they are asking transfer function. I moved on. Did anyone read this? And, did anyone do this? Yeah, special. But anyway, so a special case of transfer function is the impulse response, right? I'll have to, this is like the zero revision, zero active recall. But quickly, you can relate h of t and h of s, right? Let me mark this, okay? Let's get back to this question. I presume it's a transfer function, but no. Let's a connection is one line, okay? But with as I said, no active recall, that connection is going to take, I have to do a conceptual connection that will take time. Okay, match the different chambers, location of a healthy human heart. Column 1, 2 ranges of diastolic pressures in column 2. T80, 1812, 26, highest, right? Highest is arterial. Then, this right ventricle is pumping. So that needs to be greater than that needs to be greater than pulmonary artery. Okay. So I'm going to do right ventricle with that, and then pulmonary artery with that, because this is greater than that. Highest is arterial. Okay. So that makes this is P3 to 2 1. I have chosen C. Okay. There is any issue with the key or something like that, remind me. Okay. Most of you know the answer. Which of the following is not photoreceptor cells in a healthy human retina? Not true. C for cone, C for color, right? That is true. C for color, cone. Okay, this is true. That makes it incorrect. We can see, we cannot see colors in dark. We can see like figures and shapes, right? Distribution is not uniform. Rod and cone. So this is not true. Rods are typically higher than this. So this is a correct option, true option. This is a true option. This is false. Rods contain photopsin. I suppose this is photopsin is this color thing, right? Cones. Okay. So this is false. C. For chromatic layer, which of the following relationship holds true for the half valley layer thickness? First half valley layer is thicker than second valley layer is a unit. It cannot change. It's a constant for a given material. And see, all half valley layers have equal thickness. Group of 4 people are residing together when a virus was detected. If the probability of each person being infected is 0.1, what is the probability of at least 2 of them is infected? This is binomial distribution. Binomial. So at least 2. So 2 are infected, 3 are infected, 4 are infected, 3 terms in the summation. Just in case there are many terms in the summation, we can always do the negative probability, right? So I'm going to do that. This is equal to, 1 minus uninfected minus, that is probability of non-infected, P non-infected, probability of 1 infected. So this considers at least 2, 3, 4 in this case. We would also write it as probability of 2 infected, 3 infected, 4 infected, summation of 3. I prefer doing it as 1 minus this. So that is 1 minus 4C0, 0.9 power 4 minus 4C1, 0.9 power 3. To 0.1. Okay. Where that way, if we calculate it, what do you get? 0.052. Okay. Random noise signal with Gaussian distribution has a zero, mean zero. Hey, standard rules of thumb, area under the Gaussian curve, right? This is why 1 SD is this. They're asking you for area, probably the instantaneous measurement signal greater than that. So 1 minus at 96%, right? Is this in percentage? So this is no sigma, sigma. Um, figure my Gaussian curve is not good. Sigma, and then 3 sigma. So they're asking you for this area. Okay. We know that this area is 96%, 6.5 something like 96. Okay. Does anyone recall this? How much is this? 85.5 or some 96 point something. Can we get this area here? Area Gaussian curve standard deviation. 68%, 85.5%. Okay. So this is 95.5. 90. I had it as a 96. Again, this has to do with active recall. Okay. Again, I'm not revising, so I don't do that active recall. So 95.6. And the last one, just in case you need it, happens to be 99.73. Anyways, that is 3 sigma. So this is 1 minus that. Okay. This is 100 minus 95.5. So 4.5. Answer in percentage. Nearest integer, 4. Even if my guess is 96, nearest integer, I would have got it correct. Okay. But if you put it 96.5, I would have written at, say, 3. So this is 4. Geometric Fourier series expansion of the periodic function. The figure has coefficients a and bn or cosine sine terms, respectively. The value of a1 by a3 is given your answer rounded up to 1 decimal place. Anyone do this? So this is a 1 mark question. Again, I'm not going to, it's a periodic function. You can technically use a definition and do what is AN, right? But I'm going to do some recall here. This is proportional to 1 by n. If you look at the Fourier series of this, it's going to, this drops us, this kind of decreases, okay? 1 by n. And then you have sine of pi. Typically, there will be 2 parameters here. Pulse period and the function period. T. And what would show up here, the TP here, pulse period is 2. This is the function period is 4. Okay. So this is now the duty cycle will show up there. So this is TP by T. That is 2 by 4. Okay. So AN is proportional to 1. A3 is proportional to 1 by 3. Okay. And I think this will determine the sign. If N is 1, this pi by 2 plus 1. Let's also write it down. N 1 by N sine of n pi by 2. 1, 3. 1, 1 by 3. Sine, this will be 1, this will be minus 1. So the ratio will be 1 by minus 1 by 3. That is a minus 3. Okay. This bit I recalled, and because specifically, you're doing a 1 mark question. We don't have time to do a 2 mark derivation. Electrical engineering tissue was developed with a diameter of 2 centimeter, height of 3 centimeter, Young's modulus. If axial tensile force is 10 newtons, the percentage change in the height of the tissue is dash. Percentage change in the height. They are asking you for strain as a percentage, right? This says P by A. T by EA is epsilon. By EA is epsilon. Let's calculate epsilon. Okay. That happens to be force is 10. Let's put everything in SI. Okay. 20, 10 power 6 into area by 2 centimeter into 0.01. So that is 1 centimeter radius square. This is already, by definition, this is percentage. So all you need to do is, I suppose, into 100. If we calculate this, how much do you get? Got 0.159. 159,235. Perhaps I put pi as 3.14, or some of you put this as measured current through a device. These are questions from measure voltage, measure a product. You have to add the relative sensitivities. Maximum, is it likely or maximum? This is maximum. So, do a summation of all of that. E is IR. Let's write it this way. E is IR on error and ST. All things are products or divisions. Okay. So, and relative sensitivities. That's it. So each of them have 1 percentage. So your I percent of phi, 0.5 amps. Okay. B, this is 20 plus or minus 1% of that. This is 0.2 volts. Okay. It's also, this V by I. 4. In fact, let's let me slightly rewrite this. Okay, A am plus or minus 1%. This is 20 volt plus or minus 1%. Notice 1% is del I by I. That is 1%. Relative error, normalized error, del V by V. This is also 1%. For maximum thing, your del R by R, relative error in R will be sum of these two. 1%, the relative errors get added up for maximum thing. 1% plus 1%. Okay. So that should be 2%. 2% of what? That 2% of V by I, that is 4 ohms. How much is 2% of 4 ohms? 4 into 2 divided by 100, that is 0.08 ohm. 80 into 10 power minus 3 milli ohms. This is, I write it, 2% of 4 ohms is 0.08 ohms. Okay, that happens to be 80 milli ohms. I haven't done measurements till now, right? So this is a product division, product or division. The relative things add up. The relative things, by definition, it's not del I, absolute thing. Del I by I is a relative. So it is total 2%. Okay. Hey, let's gain some time. No, I think we are fine, right? Small frequency nucleus placed in magnetic field strength, 3 Tesla. Sodium nucleus. Gamma hash of sodium into B. Gamma hash of proton is 42.58 megahertz per Tesla. This is sodium, so this is just 11.26. 3.78. Doppler ultrasound, the probe was held at this angle. Maximum velocity of blood flow through the artery is. The probe was held at an angle. Was held at an angle of 45 degrees to the direction of blood flow. The maximum velocity of blood flow through the artery is. LF cos theta U by C F. Okay. Maximum frequency shift. You get it at maximum velocity. It's, typically we use average velocity, average frequency shift, maximum velocity, maximum this thing. So you can find your max. Now the answer ready. I'm just going to write everything, for sake of things, max. This frequency shift is 3K. Speed velocity is 1500. Ultrasound at 5 megahertz. What is this? Supposed to be 0.63. Okay, for everyone's sake, I gave that because the units are different. I gave this, and this is also in meter per second. So you'll get the answer in SI. Okay, I did that in SI. So Wien's displacement law. Wien, they're asking it for the second name. This is one question. Answer is in micrometers. Two numbers are given. Temperature, degree Celsius, okay, in Kelvin. A constant is given in meter Kelvin. It's not millikelvin, right? So if you divide one by the other, you should get answer in meters. You take this 2.98 displacement, Wien's displacement constant. Dimensional guessing, okay. 98 power 3 by, but sensible dimensional guessing. This is in Kelvin. That is, let's put that in Kelvin. We get this number, we'll just enter this up. Okay. To be 9.348 and 9.35. Two decimals, huh? Micrometers. 34835 micrometers. No, actually, 50% engineers, there are actually even this is fairly easy, right? 1 minus lambda minus 1, 2 minus 2 minus lambda. Determinant of that. 1 minus lambda plus 2 plus 2. Okay. At this stage, the roots are 0 and 1. So this question, of course, we know verification. And method 1, we know verify. Right? Method 1, verify. Okay. There is some sort of symmetry here. Just again, based on that symmetry, I could technically ruled out this one. The 2, where was anyone able to verify this? The 2, this is what I'm going to refer to as like engineering guess. Related guess. Yeah, the pressure wave equation, right? This is connected advection or transport. sport equation. Okay. So with a speed of with the speed of it should be this term should be in this side. Okay. That is a speed there with a speed of plus or minus 1 by 2. And let's write this now. At that stage, I ruled out this option. I ruled out this option. This is a speed of 1. This is a speed of 2. There is a travel forward and backward traveling wave. Okay. One is a sum and other one is a difference. Okay. And also, yeah, at this stage, I also recognize it's a sum of, okay, these are sums and differences of sum and diff of forward and backward traveling waves. Forward, backward traveling wave, traveling log. Okay, water you can call it water traveling log. In log also you will get a this is a what log rod wood footing water, right? Traveling because it is a math log traveling. Let's put traveling wave. Okay, traveling function. So it is also kind of reinforces why I ruled out option D. So I'm going to guess C and move on. Hey, that's actually a very reasonable guess. Okay. Air silic ventricular volume is found to be 125 ml. Heartbeat is this. Your cardiac output, stroke volume into HR. This is EDV minus ESV into HR. Stroke volume is 125 minus 50, 75 ml, and you got 65 beats per minute. So this is in ml. You will get answers in ml. That is 4,875 in liters. You get this 4.88. Okay, analog electronics question, diode question. This is reasonably hard. Okay. This is reasonably hard, at least for BM engineers. For BM, so you take your sine wave. The diode with the bias is going to clip it at 2. The Zener would have clipped it at Zener voltage, which is 1 volt, but that along with the bias will clip it at here. So what you're left with is this. Okay. Efficiency. This is diode plus bias, clipper. Okay. The top, the bottom, you got Zener diode, Zener reverse bias. Okay. Zener plus bias, clipper. Things are getting clipped here. Things are getting clipped there. Fine. Let's move on. T1T. Notice again use of the language, right? Short T or short T is like meaningless, right? A very, very large compared to T1 relaxation time. Very, very small compared to T2 relaxation time. This is actually very sensible language, which is what I was also mentioning, right? I couldn't find issues with the questions, right? Uh, PD, weighted imaging, what is it? TS. Have a wait for a long time, repetition. Immediately take this is long TR, short T. Quickly take it. No T information, no TR information. You will get an image this case because at short T you still have signal. At long T, you know, there is no signal. Orthopedic implant when monitored over 6 months showed the following normalized curves for polymer weight. Mass of implant mechanical. This is also actually a nice question. Among the choices, what is the most probable reason for the observed thing? Most probable reason. So, what is given as bulk and surface? If it is surface, things are typically going to go like this. There is not going to be this sudden nonlinear drop, typically. Surface. Okay. And this is what is given as bulk. So there are many visuals given. Okay, you take a piece of material. This is things are degrading at the surface, right? It's getting smaller and smaller. Bulk, on the other hand, for all, the thing remains, right? It's not getting smaller, but the properties all over it are getting degraded. So this is bulk and potential. No erosion causing mechanical breakage due to injury. If there is a mechanical breakage, wouldn't see the mass, molecular weight, and all that dropping because of mechanical breakage, right? So this is ruled out, and this is bulk. Uh, this is bulk erosion. Okay. One more question. In an attempt to integrate engineered tissue with native tissue, 3 samples of engineered tissue, XYZ, identical material properties, co-culture are into 3 different native tissues. Bone, cartilage, liver. Adhesive strength. Okay, for one material, it's engineered. Okay, 50 kPa match adhesive strength. What is the order in which um, rank adhesive strength order? Okay, so devitalized bone. This is again based on recom. Okay, this is not Young's modulus or this mechanical. This is not Young's modulus. Okay, this is adhesive strength. Be careful about it. So that for the bone highest. Then we have cartilage. Then we expect it for yeah, sort of if your engineered tissue is actually behaving like what it is being engineered, strengths are similar. Okay, its adhesive strengths are similar. Bone is going to be like in audition and bone is going to be the highest. Sort of that way. So this is X with one, the same order, right? X, Y, Z in that order. Notice you have this is less than Y, less than Z. So the same order. So I think this is option A. But catch phrase, adhesive strength. If I have to guess in the examination, I'm going to go by the functionality. Adhesion in bone is going to be the highest compared to cartilage, then liver tissue. Okay. It's a reasonable guess. Okay. In a catheter sensor system to measure blood pressure. Okay. Liquid resistance, oral. Rigidity, deflection, shearing, more flowing. Okay. Hearing molecule. Which of the following true is for oral if only radius of the catheter is double? Pressure difference across a catheter remains fixed. Distance proportional to, obviously proportional to 1 over radius power 4. The radius is doubled. Okay. Resistance will decrease by, things will easily flow. Resistance will decrease by 2 power 4. That is oral decrease by 16 times. Becomes easier for things to flow. A fluid flow, Huygens Poisson. This is like molecular shearing, right? So it's the same equation. Any of you like wondering what this is? Your R is I'm just using that. Okay. Is the value of the following integral using the residue integral method? It is a hard question. Come back to this at the end of this, okay? Else we'll kind of lose our momentum unnecessarily. A neurologist needs to improve. Everyone needs to improve. Okay. Needs to observe. It's say desperate to observe, something like that. Okay. Observe alpha waves in EEG recordings of the patient and all that. Fine. Alpha, D, tab, G, start at 3.5, double till 7. This is roughly till 14. Your alpha is in this range. Max is at 14. Okay. So this is your alpha. Alpha roughly from, 0.8, 7 to 14. Let's say 14, 13 doesn't matter. This is where your signal is. Okay. You want to filter that. High pass filter, low pass filter. Okay. First, send it through a high pass. So everything above 8. Don't want you don't want above 6 also. Above 7 I will send, okay? That's, 6 to 4 will be like 464. Also, technically, this stage, okay? Because maybe slightly systematic. I know we have signal till 14, 12, okay? I ruled it out, I ruled it out. Nyquist, because it has to be at least twice that, okay? 12 wouldn't suffice. Should you do, if you send everything above 4, everything less than 6, you will be targeting theta. So that is not correct. And then, okay, you have a signal in this range, roughly everything, send everything above 8. In that, send everything less than 12. Everything above 8, and then send there everything less than 12. Okay. So you have at 8, and roughly you have it at 12. At least you're getting the mean here, right? 7 to 14, you're getting 9, 10, and all that you're getting. Okay. And that is also at a sufficiently high, at least twice, 30, more than twice. Okay. This is correct. I highlighted that because you couldn't do 8, 12, 8, 12. You couldn't do 12 for sure. Desperate. Can you do compress sensing? It's easy. Then spots are complex, right? It's alpha wave spots are complex. What is going on in the patient, right? Uh, Anyways, he needs to observe simple thing as like, yeah, just do this and move on. If you, I know this is fairly easy, right? Instrumentation. Here below, what is the value of IR to transfer the maximum power of load? RL is orthogonal. Again, this also we know. Orthogonal across this. I don't know how you simplify it, but the way that I'm going to do that is the current, okay? Let's do everything current. Good. You have a 1 here. After conversion, this becomes a 1. It remains a 1. This becomes 5 by 1, that is 5 amps. Okay. So total there is 6 amps. Load. The 1 remains. So total there is 6 amp flowing through that. This makes it 6 volt. 6 volt RL equals this thing. Now here I know the answer. This implies RL is was 1 ohm should be equal to the Thevenin. That is 1. And the maximum current in this case is 6 by 2, 6 by 1 plus 1, that is 3. Most of you know this. Okay. You could do, you can do Kirchhoff, this and all that I just did, RLS, or Thevenin. Okay. This is notice at this stage is just Thevenin. Mechanical ventilator operating in volume control mode is set to deliver 600. Volume is controlled. Okay. You want 600 ml of tidal volume at a flow rate of rate as a constant. Kind of makes your what happens? Your pressure, you have to be concerned about it, but fine. Given what is given as flow rate as a constant, this is 40 liters per minute. And I will stop that whenever I reach, total time as like total volume as 600 ml. 40 liters per minute. How many, how many seconds I do that? So this is my inspiration. Then there is an expiration gap. And then there is a next expiration. Let's get two numbers, okay? We can technically answer at this stage, but let's just make sure all of you follow. Let's get two numbers. How long this period of breathing? How long is period of inspiration? This volume, notice what I have drawn here as flow rate. The area under this should be 600 ml. That is what you are targeting. Okay. Can we quickly get how long this should take? Length of blue line, length of red line, just for clarity. Okay. So this is 400 liters per minute. Um, Forty liters per minute. Okay. This is 40,000 ml per 60 second. This is like speed. The distance is 6,000 ml. Okay. Sorry, 600 ml. The time taken is distance by speed. Okay. I get this to be 0.9 seconds. Yeah, technically, you don't have to do this calculation, but I'm doing this. Okay. 10 breaths per minute. What is the length of one? What is length of one breath? What is the length of one breath? 10 breaths per minute. This is 10 by 60 breaths per second. That's one breath is 6 seconds. And then we have our next inspiration on that. This area supposed to be 600. Yeah. These two numbers are irrelevant, but can someone just confirm that? Let me go answer the question. I'm going to redraw this. Okay. So initially you are doing it at 40 liters per minute. This is 40. Initially you are doing it at 40. Your flow rate is doubled. You're doubling it. Reach that volume faster. half the time, in fact. This is 80. Okay. You will reach the same volume in half the time. Blue gets inspiration gets shorter. The expiration gets longer. 10 breaths per minute remains the same. Inspiratory time will increase. No. Inspiratory time will increase. Yes. Tidal volume will increase. No, this is volume control, right? At volume is at 600 ml. You are not changing the volume. Frequency of breathing will increase. No, you are again. This is the cycle also is like kind of fixed. It's 6 breaths per. I gave those two numbers for clarity. Technically, they can ask you that in any of the upcoming gate exams. But right now, does this explanation make sense? I remember some of you had questions. Darshini, Mahita, Divya Prabha, if Chanakyan is here or not. No. Okay, you have I suppose the second part, you agree with the second part, I suppose. My calculations forget, that is immaterial, okay? I just did it. Let's get back. Yeah, let's get back to this task at hand. X-ray attenuation coefficients, functions of this phantom continue. Okay, attenuation coefficients are given. We have to do at 50 and at 150. X-ray film is developed X-ray film. When the developed X-ray film is viewed, which of the following thing? Developed X-ray film. This is a negative image. Negative image. Yes. Negative image. Higher mu. Higher the attenuation coefficient. Higher the attenuation. That means higher the brightness. Attenuation is higher. The developed image, the bone will look white, right? Attenuation is the most, it looks bright. Negatively, my hair looks white. It's right now black. Mostly it's black, right? Negative, right? So higher the brightness. Higher mu, higher the brightness. So at 50, DCA has a higher mu. DCA will be brighter. At 150, so I looked at these 2 points. DCA higher mu. DCA had higher mu. At 150, bone has higher mu. Compared to, of course, this higher mu. So at 150, your bone will appear relatively brighter. Because it's a negative image, things will be like it's the upside down world. This is the opposite world. Things are this way. Fine. So the following is true for surface electromyography signal of a muscle. Hey, this is like if you're working in this field, you know this, okay? Else you'll have to refer. This is a not common thing, okay? I suppose the answer is median frequency of cortical density will decrease. Root mean square of SMCG will increase. I suppose that is correct. Can anyone quickly confirm that? This is very domain specific recall. Okay, reasonably domain specific recall. Domain specific recall. F is this. Along the part shown in the figure, give you an answer. Linear. So integral theorems. Take a derivative, some of the terms will likely disappear, right? Was green Stokes. This integration inside the this is integral of derivative inside the domain. This is summation of the boundary of the antiderivative. Okay. The way I recall that, in fact, the way I make sense out of it. So del cross F. Oh, if it's a hard digital electronics question, NIT question, you don't have time. What are you going to guess? Typically, that is also the question for very hard looking engineering mathematics questions. Some signals and systems question, this, that, and all that. Typically, that is my answer. What are you going to guess for that? Other entities, you are going to guess one. Hard digital electronics, engineering mathematics. Yeah, 0 or 1. Electronic question, 0. It is 1, right? This question, this is, I smelled, this is like toxins. Okay, I smelled a 0. Now, last minute of the exam, I might guess 0. The component, this is derivative of 0, and this is independent of z. 0 minus 0. Minus jth component. Derivative of 0. And this term is independent of z. 0 minus 0. Plus kth component. X derivative of x plus y. Partial with respect to x. That is 1. Partial of x plus y with respect to y. Right? Minus of that. That is also 0. So this term is 0. This integral is 0. Our guess supposed to be 0. Okay. 0 or 1, you can be slightly sensible. Greens is a special case of Stokes. Special case. So yeah, you could technically even this will work. Did this, technically you could also, or the dot product, dr will be in the, if you want to use greens, you could also directly find it, for the uninitiated. F is given. Use the green theorem as well. Take the dot product, this kind of becomes a integral of x plus y dx, x plus y dy. Okay. Screen should also give you that. System. It is technically, this is your green part, okay? This is your green part. That term is zero. Okay. Approximate total cross-sectional areas of various types of blood vessels are given. Estimated velocity is this. Time will it take for blood to travel through a capillary of 0.5 mm. Areas are given at this quickly, conservation. And why can we write it? Because this is total cross-sectional area. Capillaries, millions of capillaries, total, right? So we can always write this conservation equation from, the aorta section and all capillary cross section. There's not one capillary cross section. Okay, so that you can get V capillary is speed. You call the speed. V capillary is V aorta into A aorta by A capillary. I suppose cross sectional informations are given, and then this is distance by time. Time is distance by speed, right? For the benefit of units, what I'm going to calculate here is your V cap, V iota. This is 0.3 meter per second. These two areas in centimeter square units will cancel. You can put that in any units without bothering. Okay, you don't have to convert that into SI. You convert into SI, the terms will cancel. 10 power minus 2 square, 10 power minus 2 square will cancel. So I didn't do that. And your answer? What do you want is time is right. Sorry. Distance by speed. Yes. Number, whatever that number is, let's also quickly get on 2.5. I'm getting 1.67 seconds. DNA extract solution concentration 15 nanogram microcubit, sample 0.5 mm, given absorbance of 0.24 at a wavelength of 260 nanometer. Further concentration, sample was found to give an absorbance of 0.3 under initial. What is this? That is, presuming that Beer Lamberts and all that holds good. Is epsilon CL. L remains a constant, so fairly easy, right? E1 concentration 1. I'm going to get the answer in nanogram per microliter. I'm not going to change it. Absorbance 2. Absorbance 1. Does that? 23.75. Air absorbance, right? Higher concentration. Quick. X-ray beam of initial intensity 7. Okay, this is assumed to undergo attenuation through muscle tissue of thickness 16 centimeter, further through bone tissue for a thickness of 4 centimeter. Okay, inhomogeneous attenuation, right? Most of you know this. Half valley layer is given. Percentage of X-ray intensity transmitted through the it's a percentage. If you start with 100 percentage, this is going to be, if you start with 100, going to decay as mu1 x1 minus mu2 x2. This we know, but things what is given is HPL. You have to find half valley layer. So mu is on 2 by HPL. So you have mu muscle. Let's quickly calculate that. Put mu1 mu muscle. That is mu1. How much is this? You have muscle and then it goes through bone. Bone to how much is this? On 2 divided by 3.5, 0.198 on 2 divided by 1.8, that is 0.385. Thank you. And as a percentage, this is e power minus 0.198 into the units of this will be in centimeter inverse. HPL is in centimeters. So this will be in centimeter inverse. This will be in centimeter inverse. My distance is in centimeters. So centimeter, centimeter inverse will cancel. I can just directly substitute that. That happens to be initially 16 through tissue, and then 385 if you want to be like 2 decimals, or through bone. It happens to be, can just someone give me. So this is in percentage, which is what they are asking. How much is this? 53. Into 16 plus 0.385 into 4. I am getting as 0.903, 0.9023. Answer key is 0.892 is 1.0. 1.0 is far away. The answer is close to this boundary. This is exponential raised to the power, right? Make any, miss a decimal, it'll quickly go out of range because, this is like unfairly given. Sometimes happens. Person standing in 1 meter from a 4,000 curie radioactive source receives a lethal dose of radiation in about 5 minutes. So 1 second. Things are all fine. Things are fine. So fine. Standing 1 meter away from 4,000 curie radioactive source receives a lethal dose of radiation in about 5 minutes. 3 meters away, same. So 3 meters away, he will receive the same lethal dose. Same radiation, this is inverse square law. Needs a higher dosage, so higher time in this case. So how much higher? 3 square, right? 3 by 1 square higher of 5 minutes. You can write ID is I naught by 4 pi r square and all that. I1 is this, I2 is this. Higher time at a farther distance. Okay. Fine. Any of you get this question? Circular ultrasound transducer is unlike a question that I haven't given in the practice questions are like that. But any of you got this? But it's fairly straightforward, right? Pressure is proportional to sine k a square by 4r. You want reduction in intensity and reduction in intensity. So this is 20 log P1 by P2, right? How to calculate P1? So P1 by P2, the proportionality constant is not required. P1 you know, P2 you know. You have to substitute k a square by 4r. Take sine of that in degrees or radians, right? Fine. This is one question. I'll give you the numbers. So not, but you got close. What's the answer key range? I also have sufficient time, reasonable time. Okay, I hope. So far, I only left 10 questions. I have only left 2 questions. There are 10 questions down the line. I have like 1 hour, more hour, so I can afford to relax a bit. Okay. 5.2 to 5.4. So a wave f of xt minus kx. So f of xt, f of omega t. This is a spatio-temporal wave. F of omega t minus kx. Right? And whatever is inside this function should have the same, dimensions. Typically, this is radians. And that gives the k to be pi by t. 2 pi by lambda. You can take this as a definition of k. Or, looking at that, what goes inside a function of, a wave, you can also do it that way. This is radians per unit distance. Radians per distance. Lambda is distance, not s. So other things are all fairly easy. So let's calculate this k. Okay. So now your k is okay. I'm going to do it, in the space only. So your k is why? Let's do everything in SI. I get value of k. First, megahertz, 10 power 6 is 1600 meter per second. Yeah, in everything in SI. What do you get, K? While I'm waiting for that, if it is in this unit, it can peacefully go inside this sign. When you're using a gate calculator, do fine in radians, not in degrees, to be on the safer side. Sometimes, this is E925 rats per meter. Yeah, now everything as A is given, everything calculate everything in A. A is given to be what? Is 8 or 2 hours, right? Let's do that. A square by real estate issue. Fine. A square by 4R. 4R1. K A square by 4R2. So that is again, you put everything in SI, you have 3925 into A square, that is 8 square into 10 power minus 6 divided by 4 divided by R, that is 8 centimeters. 08. Absurdly large number. A square quickly calculate this 395 into 64 into 10 power minus 6 divided by 4 divided by 0.08. Got a reasonably sensible number. 0.785. If I do it for R2, that is 16 centimeters, what you're supposed to get as 925 into square. 64 into 10 power. I put 10 power 6 instead of 10 power minus 6. Divided by 4 divided by 0.6. 0.3925. Sine of term 1. This is in radians, okay? Notice K A square by 4 or 1 will be in units of radians. Let's also put that. Now, given these two, I have to change this to radians. Yeah. This happens to be. I think at this stage, sine theta is approximately theta. Okay, you use either. You should get it, but to be on the safer side. So your answer is finally T. This is in pressure amplitude. You need intensity ratio 20 log of 0.707. Oh, don't worry about magnitudes and all that they mentioned, right? Reduction in density, give your answer as a positive quantity. Don't confuse whether this is loss, increase, and all that. What do we get? No, so you got the answer, right? You got close, you got the answer. 5.4. They are teasing you, right? It's a formula. Substitute and tell me the answer. I mean, not me, the committee, right? But that's like a take home. I had difficulty. I didn't get it at the first attempt. Then, I got it at the second attempt or something like that. That's why I kind of suspected some of you would have. Pressure square isn't it? That's what I have done 20 log. I'm using amplitude. So I'm doing 20 log. So decibel is 10 log of ratio. 10 log of square of pressure is fine. Ratio of squares of pressure. That square came, right? I took the 2 here. That power came as a factor, right? Multiplication factor. Okay, because she raised that issue, don't need space here. We'll occupy our neighbor space. Okay. Now do 10 log G of amplitudes. Cannot do this. I mean, you cannot do 20 log this ratio square. Either put a square here or put it there. Yeah, fine. Square in the figure is a current source. T square. The source in the figure is a current source. And the circuit is in steady state at T equals 0. Value of V in the circuit. Give your answer rounded off to 2 decimal digits. So quickly notice by J is minus J. So this value is J impedance. This impedance is minus J. So these two impedances sort of I know that things are out of phase there, this will cancel. So whatever current is showing up, this is resistor. Same phase as and this. Right? But I need to know how the current split. That also, this is the two impedances kind of cancel each other. I can technically answer at this stage, but this implies your Z equivalence here is 2 ohms. Yeah, these two impedances kind of cancel each other, which is what I was saying. And then your current Current at this stage is the current is sine, all right? At 90 degrees, minus 90 degree doesn't matter. This is if this is one, even as a phasor, okay, this V is fairly easy. Yes, IZ as a phasor, this has the same phase as the initial current. V is also a phasor. V is as essentially 2 sin t. What I have here is a phasor. Voltage sin t. Ask one the and what they are asking you for is 2 sin 0.5 pi. That is sin pi by 2 is 1. Right? How much is that? Okay. Did any of you get this question? You've seen this, right? Impedance, phasor, and all that we are given. Typically, we do this steady state analysis, frequency response analysis. No, once you have the current in the phasors, you can get back to time domain. And in the time domain, you can always get the function value, right? Yeah, most of you, I don't think, you got it. If you got it, that is very good. Okay. And impedance EAV in the circuit given below with the dependent source. So, chart this, but to keep the dependent active, we have to apply a potential. This is finding Thevenin with the dependent source. Now, if you make it, if you apply a 1 volt there, whatever current flows here, by that current should give you the Thevenin resistance. One volt by I in amperes. Okay. We know that we have to apply this voltage to activate the dependent source. So if this is V, have a voltage of V here. A voltage of V here. Right? Is that V? I don't know. It is not volt. This is V. Okay. Let's call it Vx. It's confusing. Vx. X. Somehow find I. Somehow find I here. It's your method. Somehow find I. Ground this. Let's ground this. Your I is 1 minus Vx. Right? This is based on the resistance, that edge over there. Then your I be equal to sum of the two currents. Current that flows here and the current that flows here. Current that flows here is Vx by 1. Current that flows there is Vx minus Vx by 1. So that term goes to 0. So I is 1. Your I is Vx. Sorry, not I is Vx. Your I is Vx. So 2I is 1. How much is I? Because this implies 2I is 1. Your I is half. And your ZAB, that is a Z Thevenin, right? Which is why we are trying to find this. This is your ZAB. And ZAB equals R Thevenin. That happens to be 1 by 1 by 2. That is 2 ohms. Fine. This is finding Thevenin with a dependent source. Okay. Slightly advanced circuits, but fine. With a VGG signal ranges from 0.5 to 100 hertz. If a single ADC is used to discharge data from 8 ECG channels, minimum ADC sampling rate is. And with 100 hertz. So Nyquist sampling rate is at, sampling frequency is at 100 hertz. Which is the minimum. And then you have 18 channels. Sorry, 8 channels. Channels. So one sample, instead of one sample, you have 8 samples, right? So you have 200 into 8. Where you had one sample, now we have 8 samples. And that is your answer. 1600. This is in hertz. 59. Did any of you do question number 59? Guest. What is your guest? Digital electronics. No, this is signals and system. They summation, U1 delta convolution. Guess is 0 or 1, right? I would guess 0 here. Yeah. See, that is smart guessing, okay? There are NATs. Let me show you examples. Means displacement question. There I did this dimensional analysis. Win. Somewhere that question was there now. You're solving for problems for like 3 hours. It's like very tiring, no? So I also don't practice. I don't do practice test and all that. So here, of course, we have the dimensions, units to guess the answer. Otherwise, say I didn't notice there is this millikelvin or rated as millikelvin, that is in degrees Celsius. This is micrometers. For some reason, I read it that way. I couldn't guess it, but I would have guessed 1. This is a question answer. This is a question where I would guess 1. Okay. But any math question, digital electronics question, my guess would be 0. Okay. This is a question where I would guess 0. Oh, coming back, the question where I have to guess 0. A convolution is a summation. Summation of the summation, double summation and all that. We don't have time to do. No, there are like 5 n's or 6 n's. So I put a dot. Okay. That confusion is immaterial. This is my xn. And I don't care whether it starts at 0 or 1. Ends at 5 or 6, I don't care. H of n. What is H of n? Delta n minus delta given n. This value minus this value. What is it? Delta n minus delta n minus 1. What is that? If you recognize that, you can answer it right now. What is H of n? Forget definition of convolution and all that. What is H of n? It's a filter. Anyone? What is the spike doing? In fact, it's actually harder to see even here. Okay, delta n minus 1. Current value minus previous value. What do you think it is? Current value minus previous value. It is what we refer to. It's a derivative. It's a discrete derivative. What we refer to as a difference filter. Here is the slope. Change or changes summation. It's essentially changes. If I apply that to x of n, where are the changes happening? A change is happening here. Positive change is happening here. Negative change is happening here. So the changes are all 0. This is my y of n. Positive change, positive difference, negative difference. Where else change is happening? Hey, what is the answer now? Summation of y of n. Add all these values, what do we get? So know when to guess 0. I have to guess 0 or 1. Okay, it's like a true or false question. No, it's not a MCQ. A, B, C, D. Unanswerable NATs or like true or false question. Is it a 0 or a 1? Right? It's fair. You should guess 0 here. Okay. Fine, but even otherwise notice. So, hey, this is a convolution as a summation. This is a summation, but the meaning kind of gave you the answer, right? In the figure, the diode is ideal. Current reading shown in the ammeter is. Did any of you get this question? Let's plot this input signal. Okay. For this question, what should have been not knowingly, unknowingly, but you guessed it 0. For this question, again, 1 is not a good guess. They have given you a bridge. Better guess is 0. Okay. It's not a digital electronics question. I know. Last year, students came out of the examination, sir. Only one question answer was 1. Rest of the questions are all, there are like, only one answer key. There is like a 1, right? Hey, there are questions where you should have guessed as 0. So this is sine of t. So there is a forward. This diode will be forward. One, whether it's forward here or there, immaterial. One place is forward, reverse bias. Okay. Whether this is forward or that is forward is immaterial. Okay. So let's pull out this. Okay. So this is also sign invariant, sign of t. Okay. There is a forward and a bias. With respect to this diode, wherever there is reverse bias, ammeter current will be 0. Okay. Ammeter current will be 0. Interestingly, what happens during forward bias? So reverse bias, here is forward bias. Omega is 1, impedance is J, impedance is 1 by J, that is minus J. Plus J minus J, no, you shouldn't look at it that way. Z1 by Z2. Oh, you get 0, right, for this question. Why? Something is fishy. You smelled it. Dog smell. There is a bridge circuit. Is it balanced? You kind of smell it, okay? It so happens that out bias, this will be this. What do you mean by that? A by 1 equals 1 by minus J. 1 by minus J is J. So this is a balanced bridge. For that reason, no current through the ammeter. So your answer is 0. Okay. Actually, that's a nice question. So these are questions where I can get an edge. Right? Solution is not I someone has to explain the solution. I can get an edge. Students, I don't know how many of you can answer that or connect it. You can guess it's 0, but how many of you can connect it? It's reasonably hard, okay, for biomedical engineering, but okay, fine. Answerable question. Fourier series is this capacitor. How do we? I have I started at 2. I took like this technical issues. Started at 2. 4:30, right? I have 30 minutes left. Fourier series capacitor short circuit for all AC signals. Power absorbed by 1 ohm resistor is 1 watt. Give the answer rounded off to nearest integer. Capacitor is shorted. Then why have they given it? Because there is a DC thing. DC also capacitor short set. If you think about it, there is AC, DC. Capacitor is short circuit for AC signal. Capacitor short. DC capacitor 1. This is no power because of V naught. No power because of the unknown term V naught. No power due to V naught. Power due to this. Half. If you use RMS, it's half, right? So half of B square by R. 4 square by 1 plus. Am I getting these numbers from? got 1 here, v square by r, v square by r, v square by r. Got a 2, 5, and a 1. 2 square is 4, 5 square is 25, square is 1. Power. Power AC is half e square by. So what is technically given as the amplitudes, okay, peaks. So 1 by root 2 will be the RMS, 1 by root 2 will be the RMS. So if you are confused there, this VRMS into VRMS by R. Okay, so what is given is just V. Okay, so how much is this? Okay. This is 15. This is also a nice question. Okay. Circuits and all, they have experience setting. That's right. Artificial form of a moment of inertia. We didn't do this in class. I kind of mentioned this. ECG is 0.3 kilogram meter square, MR square. Okay. I about any axis. There is something called parallel axis here. I at a distance D is CG plus is known as parallel axis theorem. Okay. Axis through the CG, rotational axis. Any rotational axis parallel to that at a distance D. So that is what elbow CG. Okay. And then the axis, you have to presume it correctly. Okay. In this case, this is going to be how far away is it? Distance from the elbow joint to the center of mass is 20. How much is this? And of course, what they want is this. Okay. What they want is ID at a distance. Moment of inertia at a distance. How much is that? Is that correct? 0.42. A potential signal of 4 milliwatt on the skin surface was fed to an amplifier with a differential. This is something again there in the recorded video, but we didn't do it in live class. CMRR equals, by definition, in dB. Looking at gain as a ratio of voltage. Okay. So 20 log of gain of signal by gain of noise. Okay. A signal They have given a differential gain. 5 millivolt is going on, but they're given you amplifier as a differential gain. That's the gain of the amplifier signal. That's how much signal gets amplified. The noise put by input comes out as 200 millivolt. What goes in is 1000 millivolt. Use it over there. 1000 into 5 log of that into 20. What do you get? And this gain is A is gain, okay. While any of you like quickly check the number, A is gain, real estate issue. YouTube, there is a real estate issue. Simple notes also, there is a real estate issue. 0.3. Yes. In A, in A is in, V out. I'm not doing power, I'm doing V in, so I did 20. Okay. V out by V in. Sorry. How much does the output get amplified with respect to the input? That is again. 64. Motor nerve conduction velocity exponent. Distance between the distal recording sites is 4 centimeter. Distance between the proximal and the recording site is 24 centimeter. Distal and proximal frequencies were recorded at 6 millisecond and 10 millisecond respectively. Proximal, distal, the recording site. Okay. The times that latencies, latencies is, this discussion is T solution discussion plus T technical difficulties, technical issues. Initial half an hour. Of course, you're also reviewing your performance and all that. So there is conduction time. Conduction plus there is processing time. These are nerves. Take some processing time. You could give it, you can give it technical terms, but I'm going to just say processing time. But processing time is common in both latencies. To get rid of that processing time, if you do latency 1 latency T minus latency T, this is time, okay? Get E conduction for T, proximal part, T conduction for distal part. Processing is an unknown. where you record. Okay. So, okay, I got the difference in conduction times. Okay, what is the difference in distances? Right. So your velocity speed equals distance proximal minus distance by time. Okay. Conduction minus the conduction distance by conduction time. And we'll do E D E D. We'll have to be careful. This is not my regular. Okay, so this is, hey, how much? Decimal. Still in recording is 4, proximal and recording. So this is 24 minus 4 by latency is 10 minus 6. One is in centimeter technically. So let's also do that. Okay. What do you want the answer in meters per second? So this is into 10 power minus 2 and this is into 10 power minus 3. How much is the answer? Okay. Creates an apparatus shown in the figure to exercise the extensor muscle of the hand. Given that OP, OQ, of the center of mass of the lower arm is magnitude, okay. It's drawer, Edward Scissorhands hand, okay. I don't know if this is scissor or there's a cable tension going on. Okay, let's give colors. There's 50, an angle of 30 degrees. Okay. Then CG is at P, I suppose. I'm going to not read it carefully, just, I'm going to put weight of the hand 20. And then absensor muscle is acting with a momentum of 0.25. About which point one could say, because it's an extensor muscle, perhaps this is about the elbow. Only thing else, momentum about which point, right? Which point are you taking moments about? You can take moment about any point, but for the extensor muscle, perhaps they are referring to the elbow as the axis and then momentum is 0.25. Yes, that is a bit problematic. Muscle force. Let's see what happens to this. So this is almost horizontal. Let's resolve it into components. This is 50 cos 30 degrees. This is a benign component, a horizontal component, as well as it won't create any rotations. Cannot rotate the hand. This, on the other hand, can rotate the hand. 50 sine 30 degrees. How much is 50 sine 30 degrees? Let's also get the numbers. This is relatively benign. It can't rotate. Okay. So for that reason, I'm going to put that in gray. 50 cos 30 degrees. Sine 30. Sin 30 half into 50, 25. This is 25 newtons, and this is 30. It is 43.3. But that is, as I said, this is a benign component. Won't create rotations horizontally. The moment axis is momentum is zero, passing through the elbow joint. Let's look at whether is a status quo right now without the extensor muscle. Can the hand be at equilibrium? Yes. 20 into OP. How much is that distance? 0.15 in clockwise direction. Okay. And then 50 sine 30, that is 25 in anti-clockwise direction. That is OQ. This is 0.35. Can this be in equilibrium? Quickly. How much is this term? T into 0.15 minus 25 into 0.35 minus 7.75. This will tend to rotate in anti-clockwise direction unless our extensor muscle puts a clockwise thing here. We don't know the momentum, but the momentum is given to be presumably about the axis. So I'm putting that in clockwise. Okay. And the momentum, how much is that? Is it 25? Extensor muscle 25. Yeah. Where is it? Okay. 25. Okay. Has to be 0. Okay. So your T is E3. Equals E3 newtons. So this is moment equilibrium. Put summation of moments about elbow joint is 0. Summation of moment about any point is 0, but we did elbow point. And this is a presumption. Momentum with respect to elbow is a presumption. Okay, 23. Are we done? No, I have 2 questions left. Hey, which question numbers are there? Can you tell me? Can someone tell me the question numbers at 44? 44, okay. 44, and then which one? The other question? 24. Lesser of the 2 evils. Over here. 'Can you quickly tell me, is Laplace transform of impulse unit? Unit will be the impulse. I suppose Laplace transform is 1, right? First answer minus 1. Okay. So notice for impulse, y of s is h of s into 1. Convolution become a product. H of s is y of s. That is y impulse. Okay. That's it. So that is why the transfer function is working here. There is a bit of issue. Um, Someone quickly, help me. And just for what does u of t go to? My, most of my memory is in the last 10 minutes of the exam. Should be getting guessing zeros or one, filling. Yeah, this is 1 over s. Yeah. Oh, exponential e power 0t. Fine. So y impulse is h of t. Y impulse is h of t. Okay. You know that for y impulse is h of t. Okay. Y impulse of s is h of s. That happens to be our transfer function. Okay. So this is transfer function. You can stare at it. Say, there goes our answer. Okay. This is what I said. You can start from, I know I don't do revision, right? My active recall is like, I don't active recall, but, our concepts will always save us, concepts and definitions. So 44 is, help me, we can finish it in 5 minutes. Okay. Many of you are there in the meeting. And we also might need real estate issue. Can this actually this application of residue integral method, residue theorem that we haven't seen in class. Okay. This is you can find two definite integrals using uh, residues. I'll reduce the question to a familiar form. At that place, you know how to solve it. So for 1 by 1 plus x square, for the function given x power 4, okay, for f of x given, Let's also call this I. It so happens that your I is combination of residues inside contour that I have shown. Integral of contour 1, contour, contour 1, summation. Okay. Okay, now we 1D, we went to 2D, right? So this is dz by 1 plus d square. Okay. Then E2 dz by 1 plus z or 4. So it so happens that for the form function given 1 plus 1 by z square, this term is 0. Okay. And the given integral is limit t1 tending to infinity. Okay. You could say C1 is essentially, let's say, minus R to R. Okay. You have this is a integral line integral from minus R to R. If R tends to infinity, that is a given function. Reason to bring this is, notice these two together, integral along C1 plus integral along C2, that's a closed contour. This is a closed contour C1 plus C2. Abuse of notation, okay? C1 plus C2. Of the two contours, that becomes a closed contour C1 plus C2 dz by dz by plus z power 4. Do you know how to do this? This closed contour integral dz by 1 plus z power 4 happens to be summation of residues inside. Okay. Pi j, 2 pi j, 2 pi j, 2 pi j. Okay. This is a residue theorem that we have seen. This given integral happens to be the residue theorem in a convoluted way. That is slightly advanced math. Okay. AC being IAC, they give you nice math questions. Okay. So this problem you know how to solve. So what are the residues? What are the poles inside this contour? What is their residues? The poles will be roots of negative unity, fourth root of negative unity. Okay. Give me one thing, I will complete the question. Okay. So just tell me this. What is, when you write -1, if -1 is theta plus j sin theta, what is theta? Tell it to me in a nice and close to 0. Okay. What is theta? Cos is negative pi. Pi works. Minus pi. Or minus pi. Suppose pi works, right? Answer me this and then, at the stage, technically, I told you it's summation of residues inside. Now the question boils to what are the poles inside and what are the residues it gives. To proceed further, you need to tell me this. What is minus 1? In terms of, what is theta corresponding to minus 1? Pi is, my processing is totally 0, okay? So, sin pi is 0, cos pi is minus 1. At least, is that correct? Cos pi, cos 180, how much is it? Cos 180 degree, yes. Cos 180, minus 1. Minus 1 is e power j pi. Okay. Technically, discussion ends now, exam time ends now, 3 hours. Exactly, it just ended this minute in real time. Go complete this problem and leave. I need real estate, real estate. Cos 180 is minus. What we need right now is contour. Of residues inside this. The function is ez by 1 plus z power 4. This is summation of residues inside. We need to know what are the residues inside. So we have to solve for z power 4 is minus 1. That's fairly easy. So this is how my actual rough sheet looks. Okay. Actually, whatever I've been mostly solved. I solved all the problems. Okay, till calculations. So in real time, I solved the whole paper. You know that. Need space. What are the poles of this? For that, I have to solve z power 4 is minus 1. That is z power 4 is e power j pi. J pi plus 2 pi. That no, it's periodic. Okay. So z is e power j into 3 pi by 4. It's sorry, this is 2n pi. Okay. It's periodic. It's 2n pi. E power j pi. Fine. Power j pi. So this would be roots of this will be e power pi plus 2n pi by 4. Oh, 2 of this will be inside the circle. Okay. And also to simplify, note as this is if n is 0, I have e power j pi by 4. First pole, e power j pi by 4. The second pole, z2, or when n is 1, I got 3 pi by 4. J into 3 pi by 4. What is cos pi by 4? That is pi root 2. Pi by 4, pi root 2. So one pole of that is this. Notice that point, that Z1 is essentially here. The imaginary plane plus 1 by root 2, x and y is here. X is 1 by root 2, y is 1 by root 2. That point. That is our Z1. It is inside the contour that I have drawn. That will leave a residue. What is Z2? Can we also find this? What is cos 3 pi by 4? Cos 145 degrees. I suppose this is minus 1 by root 2. Okay. Plus what is sine 3 pi by 4? Sine 145. Let's again, can someone help me with this? What is cos 3 by 3 pi by 4? A cos 90 degree, cos this will be positive. Cos, no, there is some issue here. I think y will be positive. Sine, this will be positive. This is negative, and then your sine will be positive. Sine is positive, cos is negative. Okay. Let's have that till we finish this. So the second pole is over here. Minus x is negative, y is this. Z2 is over here. Those two will leave a residue. So our answer happens to be I. Okay. That happens to be sum of the residues. And the sum of the residues is the two residues inside. You can calculate the two other roots, they will be over here. Okay. They will be over here, not inside the contour that I have drawn. Hey, the roots of unity, I know they go in a circle. Okay. So, and this radius is also 3. That I know this is mod z is 3, if I remember correct. No, this is, I can draw a radius of that whatever I want. Okay. I can draw it anywhere. Anyways, this is going to tending to infinite, doesn't matter. That radius is as large as this. These two can be inside it. Notice this is pi j to residue of z1. A shorter way to do this? No, I don't think so. Pi j to residue of z2. Residue of z2. Let's say, residue of z1. Let's see what that is. Residue of z1. z1 tending to 0, z minus z1. This is z minus z1 by 1 plus z power 4, where z tends to z1. I'm getting confused with power and this and all that. Okay. Skewed z1 is power j pi by 4, and calculate this value. Residue calculation, right? Calculate it. Hard to do. So, limit, right? That also happens to be, if you use L'Hopital's rule, use Yale hospitals. What did I use? Hospital. Okay. I'm not going to, there isn't any space to write it. Now you can happily put that z is z1 as e power j pi by 4. Powers and exponential easy to calculate. So this will be by 4 e power minus a into 3 pi. Okay. You can calculate what this is. Cos 3 pi minus j sine 3 pi. How much is it, by the way? You can calculate this rule of z2. Okay. This will happen to be again the ditto e power again, and there will be 1 by 4 power minus j into there's already 3 pi. There is a z cube here. This will become 9 pi. The 4 go away. No, no, no. The 4 also remains. It's have to raise this term power of negative 3. So that 4 also remains. Okay. It's a bit messy. Okay. That 4 also remains. You know residue of 1. You know residue of 2. For completion's sake, let me write down of these values. This term happens to be 1 by 4 into, okay, cos 3 pi by 4. Okay, minus sine 3 pi by 4. And you can also get this term. You add it. This stage, okay, this will be, this will easily cancel. Is there a j in the solution? May write what this is. 1 by 4 into, there will be a root 2. There will be a root 2. And does the j, there is a 2 pi j in the residue theorem. This is question number 44, I suppose. This doesn't have any j. That j should get cancelled. J should get cancelled. That means I have a minus j here. There should be a plus j. Oh, no, no, no. It should cancel with multiplying by 2 pi j. So there is be a minus j. And what is likely is there is a minus 1 here. There should be a plus 1. Okay. You can calculate e power minus j. Will happen to be 2 pi j by 4 into j by root 2 plus 2j by root 2. That happens to be 4 will get cancelled. Minus j square is plus 1. Your pi by root 2. Yeah, at this stage, at this stage, at the very last stage, I checked the answer options. There wasn't any complex number. I knew they are going to get cancelled. So I filled the residue of Z2. Okay, I didn't calculate. I filled it up. So common test question is worth skipping in exam. Yeah, this is what I also tell you, right? I had two tough questions. I knew this. Yeah, this is the only solution. Okay, you cannot like there is no shortcut for this math question. This is worth skipping in the exam. For completion's sake, I gave you the solution. Okay. Um, this you should be skipping in the exam. I skipped it, of course, at the first pass. Once we know a 3 hour window, we are done with questions. One question left. I two questions left, right? That question number 24, right? When second came back, I had to recall a few things, right? Some concepts. Impulse response is h of t. Just a transfer function is, Laplace transform the impulse response is just a transfer function, right? I had to recall this. This we could come back and do at the second pass. Okay. But the question that I did now is a one that is meant to be skipped in the actual exam. Management technique. Rough sheet goes above one page. There, it went above one page. This moment, we should skip it. No clock, nothing. It is a sum of residues inside 2 pi j. No, I am done with my rough sheet, right? We should skip it. Unfortunately, calculated it. Actually, yeah, I completed it. I thought being a studious, he, good student, you'll go back and complete the steps. A, the sum of 2 pi j into sum of two residues. Z1 is Z2 is this. Find the residues, find the summation. I was about to ask you to do that. Like all hard homeworks will be assigned as, hard questions will be assigned as homeworks. Easy questions will be solved in class. Anyways, fortunately, I could solve it. Okay. Anyways, this brings us to the end. So the much awaited video is ready, I suppose. Solutions for GATE BM 2024 paper. Okay. And all the time management issues. So, digital electronics are 1-2 questions. You can skip it, right? Now, signals and systems, you could have skipped it, right? So, this is one of the best papers. The strategy is that I am prescribing work really well. Okay. This recorded video student got All India rank 1. Okay, of course, he also got assistance on, I have doubt on this, I have doubt on this. Okay. When also very good students ask me questions, right? It's a good question, but a cold call, right? A cold WhatsApp message, it's a good question. I feel like answering, right? But he also used to ask very good questions. This year, students, with the preparation that we did, we are here. That is very good. Okay, keep it up. And I hope this shows up in the actual GATE examination. We have many candidates, so we have probability is very high. Okay. Even if I didn't have the fortune, to have you as my direct student, scholarship student, this student, that student. But if this video helps you, I'd be, glad if you do well because of, say, this one video. Okay. It is not available, right? So right now this is there. And with that, let's stop. Okay. One of the best papers, gold standard papers. So this particular solution should live for a long time, I suppose. Okay. We are already over time. Let's stop here. Okay. Hey,